In this short lesson, I'll show you how to determine the slope field of differential equations. The question reads, construct a slope field for the differential equation dy over dx is equal to x minus 2y for points between x is equal to 0 and 5 and y is equal to 0 and 5. A differential equation such as the one we have here relates the variables x and y to the derivative dy over dx. The derivative graphically gives us the slope m of the curve, so technically we can replace dy over dx with m, the slope. M is equal to dy over dx. And the reason why I'm using m is because m is what we originally used when we were defining linear equations. Y is equal to mx plus b. M represented the slope. And of course, we can actually replace this with m is equal to x minus 2y. Using this equation, we can now compute the slope at any point pair between the boundaries that they tell us. The graph of the slopes is called a slope field, but it's also referred to as a direction field or even a tangent field. So let's go ahead and compute the slopes between 0 and 5 on the x and y axis. Here's how to do that. And this will take a while, so I will show you the first few and then I will give you the automated results afterwards. So we have at 0 and 0, m is equal to 0 minus 2 times 0, and that's equal to 0. That's your slope at 0 and 0. Let's try at 0 and 1. We have m is equal to 0 minus 2 times 1. That gives us a negative slope, so the line will be going downwards to the right. And you'll keep doing this until you reach 5 and 5. And the slope at 5 and 5, 5 minus 2 times 5, that is equal to negative 5. It takes 25 computations to get all the points and all the combinations. So to save time, I'll just show you what you should end up getting. So our next step is to graph the slopes for each of these points. We can start at 0 and 0, and then 0 and 1, and so on. Now, of course, as I mentioned earlier, that if the slope is negative, it's going to be going downwards, towards the right. And the opposite is true if it's positive. So you make small little lines to represent that slope. And it's all relative, so if you have negative 2, it's going to be less steep than something that's negative 10. So you have to keep that in mind as you create your slope field. If you've done it correctly, you should end up with something that looks like this. Okay, now that I have it on the screen, you should have something that looks like this, where you have these small lines that represent the slope, but you should not have this solid line. That's for question B. And in question B, they say, sketch the solution that has the boundary conditions y is equal to 2 and x is equal to 0. So, from here you can see, this line never goes beyond 0 from the left side, so never goes negative 1 or negative 2 on the x's, and it never goes beyond y is equal to 2. Notice that it's always behaving within x being positive and it being less than y is equal to 2. So this represents the solution to question B. And there you have it. That is how to determine the slope field of differential equations.